Hello everyone, this is Yanhong Liu. I'm working with Dr. Stein as a postdoc. Today I will show a small experiment with the title Effects of Sal CURB on Digestibility of Energy and Nutrients by Growing Pigs. So this is the outline for this presentation. First, I'll briefly introduce Sal CURB, and then I will move to the objective of these experiments and briefly show the materials and methods and results. And finally, I will give several key conclusions based on the results. Lastly, I will leave you with a key implication based on this experiment. The FDA lists 37% formaldehyde aqueous solution as a feed additive. The recommended dose is 0.1% pure formaldehyde in feed. So the formaldehyde can be used as an antimicrobial agent to maintain feed negative for Salmonella. And recently, research also reported formaldehyde can be used as a potential alternative to reduce contamination with PEDV. Sal CURB is a product from Chemi Industries. Sal CURB is a blend of 37% formaldehyde aqueous solution and propionic acid. From the previous slide, you know the formaldehyde can be used to control Salmonella and PEDV in the feed, and the propionic acid is used as a chemical preservative for control of mold in feed or feed ingredients. A lot of research have been reported on the effects of formaldehyde use as a feed disinfectant, but there are limited research on the effects of formaldehyde on nutritional value of feedstuffs fed to pigs. Therefore, the objective of this experiment was to determine effects of Sal CURB on apparent total tract digestibility of energy, calcium and phosphorus, and apparent ileal digestibility of crude protein, amino acid in a diet fed to growing pigs. The second objective was to determine the effects of Sal CURB treatment on phytase and vitamin stability in premix. In the next few slides, I will briefly show how we conduct this experiment. From this slide, you can see a table for diet formulation. We use two diets, control diet and Sal CURB diet. Both diets were based on corn, soybean meal, DDGS, and oats, and both diets contain 0.5% chromic oxide as an indigestible marker. The only difference for these two diets were the control diet contains saline-treated base mix, and the Sal CURB diet contains 32.5% Sal CURB-treated base mix. In this experiment, we used 8 growing pigs with initial body weight around 27 kilograms. All pigs were installed with T cannulas in the distal ileum. The experimental design was 2-period switchback design. Therefore, at the end of the experiment, we had 8 replicate pigs per treatment. In each period, the first 4 days were adaptation period, and the fecal samples were collected on day 5 and 6 in the morning, and the ileal collections were started on day 6. After the fecal collections, we collect 8 hours per day on day 6 and day 7. And this slide just showed how we calculate the apparent ileal digestibility. This is a traditional equation we used for the AID of amino acid and crude protein, so I will not show the detail about this equation. We calculate the AID of crude protein and amino acid, and also we calculate the ATTD of energy, calcium, and phosphorus based on the indigestible marker. As I mentioned before, the second objective of this experiment was to determine the effects of Sal CURB treatment on phytase and vitamin stability in base mix. So therefore, we collect 24 subsamples of each base mix during diet mixing. We send 3 random samples to analyze phytase and vitamins on day 0, and the remaining subsamples were stored in feed meal during July to August. And we send another 3 random subsamples on day 7, 28, and 49 for phytase and vitamin analysis. For the statistical analysis, for the digestibility trial, all data were analyzed using ProcMix with a randomized complete block design. The model includes diet as fixed effect and peak and period as random effects. And for phytase and vitamin analysis, all data were analyzed using ProcMix also with a completely randomized design. The model includes treatment, day, and their interaction as fixed effects. Now let's move to the results. In this slide, I have the apparent ileal digestibility data, and in this figure, I have the AID of methionine. First, let me set up the figure. I have the orange color represent control diet, and light blue represent Sal CURB diet. and the y-axis I have the ileal digestibility value. So from this figure we can say Sal CURB treatment increased the apparent ileal digestibility of methionine. But there was no difference in the AID or crude protein and other amino acid observed between control and Sal CURB diets. This slide is for apparent total tract digestibility of energy, calcium, and phosphorus. First, let me set up the figure again. So we have the similar color represent the same diets, orange color for control diet and light blue for Sal CURB diet. In the x-axis, from the left to right, we have an apparent total tract digestibility of energy, calcium, and phosphorus. Compared with the control diet, Sal CURB treatment did not affect apparent total tract digestibility of energy, but compared with the control diet, Sal CURB treatment increased the digestibility of calcium and phosphorus. We do not have a good explanation for this result because based on the ruminant data, Sal CURB treatment decreased the digestibility of phosphorus. So more research in the future will be needed to figure out the findings from these experiments. So this slide shows the phytase concentration in base mix. So again, we have the orange color represent saline-treated base mix, and light blue represent Sal CURB-treated base mix. And in the x-axis, from left to right, we have day 0, 7, 28, and 49. And the y-axis, we have the concentration of phytase. So from this figure, we can see as the storage time increased, the concentration of phytase was decreased, and the Sal CURB treatment decreased the phytase concentration regardless of storage time, but there was no interaction between day and treatment. The next two slides, I will show the vitamin concentration in base mix. So from this figure, you can see we have the vitamin B1, B2, B3, B6, and vitamin K3. So in this figure, I only show the day effects on vitamin concentration. As the storage time increased, there was no difference on vitamin B1, B2, B6, and vitamin K3 concentration. But as the storage time increased, the concentration of vitamin B3 was linearly increased. In this figure, we have the concentration of vitamin B7, B9, and B12. So from here, we can see as the storage time increased, the concentration of vitamin B12 was linearly increased, but the concentration of vitamin B7 and B9 was linearly decreased. And this figure, we have the choline concentration and the vitamin D3 concentration. There was no difference from the day effects on the choline concentration, and also as the storage time increased, the concentration of vitamin D3 was linearly increased. And the last figure showed the vitamin B5 and the vitamin E concentration. As the storage time increased, again the concentration of vitamin B5 and vitamin E was linearly increased. As I mentioned before, the last four figures only show the effects of day on vitamin concentrations because we didn't find any difference from the Sal CURB treatment on the concentration of vitamins compared with the saline treatment, except vitamin B1. Sal CURB treatment increased the vitamin B1 concentration compared with the saline-treated base mix. So based on the results from these experiments, we conclude supplementation of Sal CURB does not affect the digestibility of energy, protein, and amino acid. Addition of Sal CURB increased the digestibility of calcium and phosphorus. As I mentioned before, more research will be needed in the future to clarify the Sal CURB effects on the digestibility of phosphorus and calcium. Base mix treated with Sal CURB can be stored for 49 days without degradation of most vitamins. The phytase in base mix degrades over time, but not below adequate levels. But the phytase concentration were less in Sal CURB treated base mix compared with the saline treated base mix. The results of this experiment indicate Sal CURB can be added to swan diets without diminishing the nutritional value of the diets. Finally, thank you so much for your listening to this presentation. If you have more questions, you may get more information from our website. We have a research report related to this presentation.